Welcome back to another BGCSE past paper review. Today we're reviewing a combined science paper. This is a paper 1 from the year 2018. Please remember to write your school name, your candidate number, your surname, and also your initials. Again, read through the instructions carefully before you start the examination, and also follow the directives of the examiner. Again, they provide you with a periodic table just in case you may need to refer to it. All right, so let's go into our first question here. And the first question here reads that which part of the periodic table is the element krypton? And so you can look at the periodic table, you will notice that it is a noble gas. So C will be your answer right there. And then for question number 2, it says the diagram shows 4 organs of the digestive system. And so A is the liver, B is the large intestine, C is the stomach, and D is the small intestine. And it said which of the structure A, B, C, or D contains villi, and villi are present in the small intestine, and those are important for absorption of digested nutrients. Now let's go to number 3. Number 3 said which symbol represents a closed circuit, which means the switch is on, and so this here is C. All right, A is open circuit, C is a closed circuit, that means the switch is on, B is a fuse, and D is a battery. For number 4, it said what term describe animals that are hunted for food by other animals, and so these we call the prey. The predator is what do the hunting. All right, so let's jump to question number 5. And for question number 5, it reads that the diagram shows the energy flow in a food web. And you have a decomposer, you have plant, you have herbivore, you have carnivore. The question reads, which arrow does not show the direction of the flow of energy? And so if you look at the food web carefully, you'll notice that from plants to herbivore, that's correct. From herbivore to carnivores, that's also correct. And then from carnivores into decomposers, herbivore, they also will release some energy for decomposers, and especially when they are dead. So going back to the plants, energy is not being transferred. However, nutrients, the plants will absorb nutrients. Remember that plants take their energy from the sunlight, okay, or light in general. So D will be our correct answer. All right, so what is happening at D is absorption of nutrients, not energy. For question number 6, it's a diagram shows the main structure of a flowering plant, but there's no flowering plant right here, so this is a typo. So let me just get rid of that little piece right here. All right, so what is showing right here, it is showing the water cycle. Okay, so this shows the water cycle. And so let's go to the question. Matter of fact, the question says what 2 processes are taking place at Y and Z. There's no Y and Z there. But what we can talk about, we can look at the processes at each point. And so right at this point here, we can call it evaporation. So you'd have evaporation right here. Okay. Evaporation taking place at that point, just in case you need it. From where after evaporation to form cloud, then you could have condensation. That is cooling. So condensation. And then after condensation, coming back to the earth, which is rainfall is an example, snow, hail, and sleet. So this is called precipitation. Okay. And this are going from the plants going back in the atmosphere. This is called transpiration or evapotranspiration. This is transpiration. Water loss from the plants. And then coming from the soil, coming back into the pond or lake, that is called runoff water. Okay. All right. This is runoff water. All right. So that will be the labelings if you should need to label these processes. All right. So we can jump back into now another question. All right. So this is a typo question. All right. So let's now go into another question here. All right, so we're jumping to question number 7. And for question number 7, all right, for question number 7, let's just get back my thing right here real quick. All right, so question number 7 reads that the diagram shows one way of measuring the diameter of a ball. All right, and so what is the diameter of the ball? So first and foremost, you have to figure out now where the ball is. And so the ball is measured with the inner portion right here. So I'm going to mark this line. So that is on 5. And this one here going to be on 7.5. So to get the diameter of the ball, it's going to be 7.5, right? 7.5 minus 5, okay? And so that will equal to 2.5, right? So the answer there is going to be 2.5. So 7.5 minus 5 should give us 2.5. So our answer here will be C. Okay. All right, so great. Now, number 8, it's a diagram shows the structure of the human arm. And so that's what the action is. So which structure shows an effector? And remember that effector, they are inside of muscles. All right, effector cells are inside of muscles. So C is the only muscle shown. So C will be your answer right there. All right, and so let's go to question number 9. It said the diagram shows a sensory neuron. And we know it's a sensory neuron because the cell body is on the side. Just please remember that. All right, and the branching part would be the dendrites, and then the nerve endings on this point. And all this structure right here in the middle will be your axon. Now the question now asks what would happen if the myelin sheath was removed. And remember, the myelin sheath is to insulate the neuron and allow impulses to travel faster. So therefore, this one is a impulse will travel slower. That will be your answer right here. Right? So once you know the function of the structures, then you can actually know exactly if they're missing, what will happen. All right, so let's go to the next question. I'm trying to go through this really fast today. All right, I'm really strapped for time. Number 10 is that the diagram represents a reflex arc. All right, and so we have point 1, point 2, point 3, 4, and 5. All right, so point 1, this is where the stimulus is. Then you have a sensory neuron, then you have a relay neuron, then we have the motor neuron, and then the muscles. And in the muscles, we have effector cells. All right, so now let's go to what they're asking us. They said, which row shows the path of impulse from the fingertip to the muscle in the arm? And so the first thing you should have there, you should have a receptor, all right, or at least a sense organ. So the one that started with receptor will be your answer. So only B or D could be the answer. After receptor comes our sensory neuron. So sensory neuron is next. And so B look like the good answer right here. So first we will have our receptor cells in the sense organ. Then we have our sensory neuron. And then we have our relay neuron, then motor neuron, then the effector cells that are present inside of the muscles. Okay, so B is definitely the answer right here. All right, so let's go to the next question. And for question number 11, it said, why is this reaction a chemical reaction? And so magnesium plus oxygen give you magnesium oxide, and simply because a new substance is formed. Chemical changes always produce new substance. All right, for number 12, it says an unknown element is tested using the apparatus shown. The lamp did not light up. Which statement could describe the element? And so first and foremost, the element here is an insulator. All right, and so if it's a metal will transfer electricity, so they are conductors. Alloy, same thing, they are metals, made up of metals in the first place, so definitely they will transfer electric current, so they are conductors. So non-metals are not good conductors of electricity, so C will be your answer. All right, a transition element, they are metals as well. Transition elements, they are metals. All right, so definitely C, non-metals. Non-metals are poor conductor of electricity. Now, for this part, it's a question 13 and 14 relates to the diagram which shows a side view of the structure of the knee. And so 13 state which two structures work with antagonistic muscles to cause movement. So it's a work with antagonistic muscles to cause movement. And so P is a bone and R is a cartilage, right? And Q is also a bone, which is the patella, but the patella is connected to two muscles. And so just to make it clear right here, all right, and S is also a muscle, all right? So we say work with antagonistic muscles. So the cartilage is very important in this because the cartilage will cause smooth movement. And so the patella also connect the two muscles, all right? So what is important here, right, for us is the patella and the cartilage. So we're looking here for Q and R. Okay, so Q and R will be the answer. So this will be B. All right, they assist with the muscles for movement. Okay. All right, so question number 14, it said which structure protects the end of bones where they meet to form a joint. And so what you find at the end of bones is cartilage, and cartilage is represented by R. All right, and they are also called shock absorber. All right, so R, which is C, so option C here is the correct answer. All right, number 15, it said which element is a metalloid, and you can go back on the periodic table, you will see it. Chromium is a transitional metal, so that cannot be. All right, germanium is the answer. All right, so you notice you see fall on the staircase. And then manganese, a motherfucker, is a transitional metal, and then sulfur is a non-metal. So the answer there is germanium. Let's go to question number 16. It said which diagram shows the magnetic field for a bar magnet? And just to point out a few things right here, really quick, is that the field will leave from north to south, so it always go into south and leaving from north, right? And so if you look at diagram 1, you notice that you're leaving from north, going into south, so all the arrows are going towards the south, so this one seemingly good. Let's get B. Yes, this is leaving from north, but this part here is going back and forth, which is not correct. These two are also incorrect because they're leaving south. They always go into south, just to make a note of that. For this C diagram right here, it is leaving, this line is leaving south, and these two are going towards the north, which is not true. Okay. And for diagram D, this back and forth arrow right here is not true, and also these two on this side, they're not true because they're leaving south, not correct. And even this going back and forth is not correct. So the only correct answer here is A. Okay, so A will be your correct answer. All right, so just to point it out. All right, let me delete that and redo it. A is our correct answer. Great. All right, so let's go to question number 17. Number 17 states which row matches the hormone with its function. And so estrogen, let's start with estrogen here. Estrogen, breast, body part affected is the breast, which can be true, but the increase in milk production is not true. Estrogen will stimulate the development of the breast, but not to produce milk. Estrogen, hip, girdle, and increase in overgrowth. That is not true. Testosterone deals with the face, yes, and its increase in hair growth, which is a true statement because in males they will grow facial hair, definitely. So this will be a correct answer. Testosterone deals with penis, increase in sperm production. Yeah, but it does not affect the penis, it affects the testes. All right, so that is C. For number 18, it said which structure does not match its function. And here, cervix opening, said does not. So cervix is the opening of the uterus into the vagina, which is correct. The placenta, it forms a protective fluid-filled sac around the developing fetus, which is not true. The placenta, that is the filtering organ and the organ that supplies nutrients to the baby, or it is the organ between the baby and the mother in terms of supplying nutrients and filters the mother's blood. What forms a protective fluid sac? That is called the amniotic sac. Okay, so this is not a true statement right here. Umbilical cord connects the fetus to the placenta, definitely. Uterus, where the fetus develops, definitely correct. So B is the incorrect statement. Number 19, it said 5 drops of soap solution are made to equal volumes, right? To equal volumes of different sample of water. The 4 test tubes were shaken and the results obtained. Now, first and foremost, they say lather. That is lather, which means the soapiness in the water, right? And so here now we said which test tube contains soft water. Soft water means that there's no impurities in it, right? Or nothing added to the water. So pretty much the water is almost pure. And pure water will produce the greatest amount of lather or suddenness, right? And so therefore C will be our answer right here, okay? Scum, more scum mean that the water is hard, okay? Which means the water is also impure. So D will be impure, okay? B will be slightly impure, all right? There are some impurities in it. A definitely is have some lather, so it's not too bad, but maybe a little deposit. But this, for the fact that C has the most lather, it is the softest water. Okay, A is also soft, but not as soft as C. All right, so number 20. For number 20, so the distance against time graph shows the motion of a car. And I said, which row describe the speed of the car in section X and section Y? And so what is happening in section X? You notice the distance is increasing with time. And if distance is increasing with time, remember distance over time. And so I could show you something real quick. For example, if I put a line right here and put a line right here, let's say this is 2 and this is 1. The speed will be 2 over 1, right, which would be 2 meters per second. And if I put 1 here and call this 2, it may go up to 4. And so 2 over 4 gives you 2 as well. So therefore, it will be 2 meters per second. So you'd have a constant speed there. The same thing on this line going down like this is just the reverse way of X. So both sides will be constant speed. So A, yep, A will be your answer in this case. Yep, both constant speed. All right. And remember, it's distance over time. Increased distance over increased time will give a constant speed. All right. So 21 is that the graph shows the effect of different pH on 2 enzymes. What is the total amount of substance produced at the optimum pH of both enzymes? Now, the optimum pH, first and foremost, is a point where the graph is the highest. So right here, in terms of amount of substance produced, that is the highest. But how to calculate this now? They ask us for the total amount that is produced. So what you're going to do here is to draw a line coming all the way over. So this will be the line before the 40. Okay. So and for between 30 and 40, there are 10 lines, right? So therefore mean each line is 1. So this is going to be 39. I could put my 39 right there. Okay. And for this one, it comes all the way below 30. All right. So this line go all the way over from the top all the way over to 30, just below 30. All right. Ignore my crooked line. Okay. And so this will be 29, right? And so if you add up, if you add both 39 and 29, you'll get 68, okay? That both of them give you 68. So the total there should be 68. So let's go to our answer right there. And 68.5 will be the closest to 68. So yes, that will be it. All right. So that will be your answer right there. All right, let's go to question number 22. It said, which element is a liquid at room temperature and produce a brown gas? So there are two things looking for: liquid at room temperature. Okay, so liquid at room temperature, and it produces a brown gas. So that's now two things looking for. Okay, so off the bat, we know that bromine will produce brown gas. So bromine is a good choice. Chlorine will be a colorless gas right there. All right, mercury is a liquid, but it's not produce. Well, mercury don't produce any gas. All right, and but for the fact that brown gas is included, then bromine is the correct answer. Okay. 23. It said diagram shows a circuit in which all the lamps are lit. It said the lamp mark X blows and breaks part of the circuit. So let's take lamp X out of it. So again, lamp X is no longer in the circuit. So it's not working. Okay. So if it's not working, remember now current cannot flow through it, right? There's no way current could flow through it at all. So if I put an arrow right here, the current cannot pass, right? So I say how many lamps will remain on. So if X is out, that means this one will also be out as well, because these two are in what? Series, okay? So this part of the circuit, I'm put a line right here. All of this part of the circuit will be out. None, any of these two, they will not be on. But this lamp will be on, this lamp will be on, because they're still connected directly in the path of the battery. Well, this is a cell because it's only one thing together, right? All right, so now we're looking for 2, will be an option right here. So this will be C is the correct answer. All right, and so let's jump to the next question. It said the diagram shows a tooth. It says 6 shows a tooth. 6-year-old Lisa is missing all of her teeth like the one shown. All right, and so this is an incisor. This is an incisor. Notice how it's shaped like a chisel. It said, which problem will she experience when eating? And so you need to remember, first and foremost, what is the function of the incisor teeth. All right, the incisor teeth is generally for, is called a biting teeth, a matter of fact. That's the name of it. It's a biting teeth. That's the name for it. And so you have difficulty in biting piece of food. Okay, so A will be your answer. Okay, the molar and the premolar, they are used for grinding. Okay, they're used for grinding and also for chewing. All right. There's no teeth used for swallowing. All right, the tongue is used for that. All right. All right. So, and the canine teeth is used for tearing. Okay, just to make a note of that. All right. The 25, it said, which of the following explains why many covalent compounds have relatively low melting and boiling point? And this is because of weak bonds. Okay, so the bonds, they are weak. So it's a bond between the ions. For A is very weak. Now this is a problem because they use the word ions. Ions are not in covalent compounds, right? We put ions in. Ions are in ionic compounds, so that's something that we need to point out right there, right? But again, strong bonds not correct. Again, the molecules is strong. In C is not correct. So the only correct answer here is that the molecules, the bond between the molecules is weak. Okay, so D is your correct answer. Okay, so anything with ions, not true for covalent compounds, right? All right. So 26 here now, so the diagram shows a ray of light. So this shows a ray of light passing from air into glass. Okay. And just to make a note here, because air is optically less dense and glass is optically more dense. And if you notice, the angle of incidence will be greater in optically less dense object and smaller in optically more dense object. Okay, just to point that out. So again, angle of incidence we are putting here is greater than the angle of refraction. All right, so just to make a point right there. Okay, all right. So it said which labeled angles are the angle of incidence and the angle of refraction. Okay, we just talk about that. So X is incident angle, that is going in, and refraction is what is coming out. Okay, so going in is incident, coming out is refraction. So the angle of incidence is X and refraction is Z. So let's look for X and Z, and X and Z respectively is D. All right, great. Now let's go to question number 27. It said diagram shows structures in the middle ear, and it said which letter represents the malleus. Now I'm going to tell you something, that the easy way to remember the 3 bones, the 3 smallest bone in the body, all right, which are found in the ear, is asmis. Okay, so I'm putting it right here, asmis. So H, A, S. All right, so asmis, I'm going to put miss over this side, which is M, I, S. Okay, and so there are 2 names given to each of these bones. So the first bone, the first one could call hammer. Okay, so it's called hammer. Okay, the second one is called anvil. Okay, so it's anvil. Okay, and the third one is called stirrup. Okay, Just to make you know this, stir up. And Amr is the same thing as malleus. Okay, so as I say, has miss. So it is also called malleus. The first one is called malleus. Let's get into it. Malleus. Okay. And I represent incus. Okay. So we have incus right here. So this one is incus. And then S again, stapes. All right. So those are the three bones of the body. So the first one is the malleus. And so B is the first bone. So this is malleus here, incus, and then stape. A is the eardrum. Okay. All right. So we know that B is definitely our answer right there, as miss. As miss. The three bones in the human ear. And these are three smallest bone of the body. All right. Number 28. Okay. Which of these is not a solution? Not a solution. And so a solution contains a solute and a what? Solvent. So dilute sulfuric acid, yes, it's a dilute. That means water is added to this, to the acid itself. All right, so it's a solution. Distilled water, that means it's distilled water, means it's pure water, nothing in it. So definitely this. I don't even need to go any further. All right. Iced tea, seawater, they are solution. They contain solute and solvent. Now for question number 29, right? It said the diagram shows an electromagnet. Okay. It said the strength of electromagnet may be increased by, and there are two things that increase the strength of electromagnet. Okay. So electromagnet are increased by, it said the strength of an electromagnet may be increased by one, increase the rate of current. Increase the current is, yes, that is true. Increase the number of turns in the coil and increase in the diameter of the coils. And it said, how could you increase the strength? How could you increase the strength of the electromagnet shown? And so these are three things here that may increase the strength of the magnet, which is true. And so first and foremost, let's point this out real quick, right? Is that more current, right, will create a greater field. Increase number of turns, also important because that will generate a stronger field as well. Increase the diameter of the coil is important because when you increase the diameter of the coil, what you're doing is allowing more current to flow. Okay, you're allowing more current to flow in this sense. So in terms of this now, in terms of this magnet, like I said, for this magnet, how could you increase the strength of the electromagnet shown? And so the battery is there, which will produce a steady current, all right, unless you add more batteries to it. But in terms of the wire, you could increase the number of turning on the wire, right? Or you could use a thicker wire with the same amount of turnings, right? So therefore, 2 and 3 will be the best option right here. Okay, but remember, all three of them can also increase, right? So let's go with here, 2 and 3. Okay, all right. But remember now, in general, right, just to make a note of it, in general, if you should answer this question, let's say paper 2, the two things that generally increase, right, which is effectively increasing any electromagnet, is increasing the number of current and also increasing the number of turns. So current and turns are the two main things that are used to increase the strength of electromagnet. Increasing the diameter of the coil, right, or the wire, let's say the wire here, just to point this out real quick, right, is that if you should do this, I want to just quickly tell you this, what's going to happen here. Again, if you use a thicker wire will end up having less turns, right? So this increasing the wire will give you less turns, will give it the same strength, okay? So this is like not even changing the strength of the magnet technically, right? Because it compensates, the current will compensate for the number of turns, right? So again, if you should answer this on a paper 2, increasing the current and increasing the number of turns is your answer, okay? Just to point it out. But again, if you have a set number of batteries, the current cannot go any further, all right? Just to point it out as well. A matter of fact, by using it over time, the current will also decrease, yes? All right. Question number 30. It said urea is produced in one organ, filtered from the body by a second organ, and stored in a third organ before it is expelled from the body. Which organs are responsible for carrying out these actions and or functions? And so first and foremost, what produces the urea is the liver by a process called deamination. Okay, so liver is what? So we know that it must be between C and D. It is filtered by the kidneys. And matter of fact, it is filtered by the nephrons in the kidneys, just to make a point there. And it is stored in the urinary bladder. So D will be our correct answer. For question number 31, it says which method moves hardness from water? And again, we talk about the distilled water up top being pure. Okay, so distillation is the answer right here. You distill it, that means you're going to get water evaporated, you cool it and collect that pure water. Okay, filtration, some substance that dissolves in water will still be in the water, right? Boiling will cause the water just to evaporate. And centrifugal fugal would just simply put the solid to the bottom of the water. Okay, okay, all right. So 32, it's a diagram shows an ammeter measuring the current in a circuit. What is the current reading on the ammeter? Now, first and foremost, establish the number of lines right here. Going across from 0 to 1 is 10 lines, right? So that means each of these line will be 0.1. Okay, so therefore this is on the second point right here, so it's going to be 0.2. So this is definitely 0.2 amperes. Okay, just to point it out real quick, the second marking is 0.2. So our answer here is 0.2 amperes. All right, going to the next question here, moving a little bit fast, right, to finish this in time. All right, so 33, it said which of the following has a definite volume and an indefinite shape when measured at room temperature? In other words, now, this substance here is actually explaining, say, definite volume, explaining a liquid, okay? Because first and foremost, what you need to understand in terms of definite volume, gases do not have a definite volume, right? Because they will definitely take up the space available to them. That's first and foremost. All right, so a liquid will have a definite volume, but the shape of it is based upon the container. So chloride is a gas, so the gas will have indefinite volume and indefinite shape. Ethanol is a liquid at room temperature, so we could actually talk about this one. Yeah, that is good. Air is a gas, definitely. Iron is a solid, and iron, that means it has a definite volume and also a definite shape. Okay, so the only correct answer here is ethanol. Okay, so B is the correct answer there. Now 34, it's a diagram shows a portion of a nephron showing blood entering the capillary at P and leaving at Q. Okay, it said which amount of substance in the blood remains the same at P and Q. So this is just the glomerulus here. Things leaving the glomerulus and entering the glomerulus and leaving the glomerulus. But what is going in here, which is a filtrate, or they call it glomerular filtrate, it contains glucose, urea, salt, and water. So the only thing that is not filtered is protein, because protein molecules are too large. And remember, please remember, the process that's taking place with this arrow is called ultrafiltration. The only reason why protein is not passed through it, or passed through the capillaries into the Bozeman capsule, is simply because the protein molecules are too what? Large. Now 35, it said the table shows the amount of water and salt lost from the kidneys and the skin on a hot day and on a cold day. Now, the food and drink intake are the same on both days. Okay, so let's just mark it out. On both days, the food intake and drink intake, they're the same, exact same thing. Now, it said, what does these results show? Okay, and so let's go to the result here. It said less water is lost from the kidney on a cold day than on a hot day. So look at water from the kidney. On a cold day, you have more water lost from it, not less. Okay, so 1.8 is more than 0.4, right? So option A is not a true statement, right? That is from the result. All right, if you look at part B now, it said more salt is lost from a kidney on a hot day than on a cold day. So look at salt. Actually, on a cold day, right, you have more salt is lost from the kidney on a cold day, but not on a hot day. So this is also wrong as well. So that is not true. Now for part C, it said the total amount of salt lost from the kidney each day is the same. And so if you look on a cold day, it is 20.3 and also 0.1. That will give you 20.4. Okay, that's 20.4. And on a hot day, it gives you here 20.2 and 5.8. If I put both of them together, you get 26. Okay, so on a cold day and a hot day, it is not the same, right? All right, so notice that the total amount of salt lost each day is the same, which is not showing the correct result right here. They are different, in fact. All right, so this is also an incorrect statement based on the result. And so water is not lost from a kidney on a hot day. So on a hot day, it's a water is not lost from a kidney, which is not true because water is here with the 0.4. It is some amount of water, isn't it true? Okay. However, no, there's one thing in the statement because these are not actually correct answers here. But based on the statement, it said the same food intake, right? And the same things were happening on the same day. So by information right here now, if you do the same intake of water and the same intake of food, then you lose the same amount of salt on each day because everything is constant. The difference is that on one day you sweat more, you lose the water through sweating more, or you use the salt through sweating more versus urination. That's the only difference. The difference is how you lose it, but not the amount that you lost, because it will be the same. Okay, thus that is divided between sweating and also urination. All right, so C will be the answer, but it's not correctly shown in the table at all. All right, for question number 36, it says a student stands 2 meters away from a plate mirror. Okay, and the distance from the mirror to the person here is 2 meters. So that's very important right here. It said, what will be the distance from the student to the virtual image? And first and foremost, I want to point this out that in terms of a mirror, the image is the same distance behind the mirror as the person in front of the mirror. So what I want to point out right here, not drawn to scale, right? But this distance here, the image distance, is also 2 meters from the mirror itself. So the distance from the student to the image behind the mirror must be 4. Okay, so this is 4 meters here, accounting for those two distances. Remember, the image behind the mirror is the same distance with the object in front of the mirror. Okay, so the total distance there from the students to the image is 4 meters. So this has to be B. Okay. All right, so let's jump to the next question now. All right. And the next question, which is question number 37, is which substance will be a liquid at room temperature? And the temperature they're talking about here is 20 degrees. It therefore means that the substance must melt at 20 degrees or below 20 degrees. Okay, must melt. So the melting point there must be below 20 degrees. Okay, all right. And also must not boil above 20 degrees. So that's very important. It must melt at 20, right? Or below 20, and it cannot boil at 20 or above or below 20. Because so let's analyze A first. A is definitely liquid, right, before 20. However, it's also boiling at negative 13, which means before it reaches 20, it's already a gas, yeah? So it cannot be a liquid at 20 because it's already a gas at minus 38. So this is not correct. Let me strike those out. All right, so if it's boiling before 20, it is a gas before it reaches 20. For B, it is melting at 34, which means it is a solid at 20 because it only started to melt at 34. That means at 20, it was a solid. Okay, so this is not true. So this here will be a gas at 20 degrees Celsius. So this will be a gas. All right, this will be a gas at 20. All right, at 34, this will be a solid still. So this will be a solid because again, it only melts at 34. So this will still be a solid at 20 degrees. 0 degrees is melt at 0 degrees. So that means before it reaches 20, it is a liquid. But it will not boil until it reaches 100. So therefore mean it is a liquid at 0. So it's a liquid at 0. It did not turn to gas until it reaches 100. So definitely this is looking good. All right. 114 melts at 114. We can move on from this because this is not, if this is melt at 114, that means it already a solid at 20, right? So let's just choose our answer right here. It is C. Okay, 114 melting at 114. It's already a solid, all right, at 20. All right. So let's go to the next question here. 38. It's an athlete runs 400 meters race, which results in oxygen depth. Now, is what happens to the athlete towards the end of the race. Now, to repay that oxygen debt, what you must do is to breathe harder, okay, to supply more oxygen. So breathing rate slows, which is not true. That is not correct. Is a carbon dioxide levels in the blood decrease. Not true at all. All right. But oxygen demand exceed the oxygen supply, which is true. That's why we get into the debt, a matter of fact, right? Because the oxygen demand is so great, you start to breathe faster and faster and faster, and so it exceed what is being supplied because you need a lot of energy. You start to breathe harder, heart rate increase, and so on. Okay, and cell respire aerobically, not true. The cell will start to, the cells in the muscle will start to respire anaerobically and produce lactic acid. Okay, just to make a note right there. 39 is a solar panel is used to heat water. The hot water is then stored in a water tank and is returned to the solar panel for heating when the water cools. Now, it said there is no pump. There is no pump to move the hot water to the tank, to the water tank, and the cooler water back to the panel. So there's no pumping valve, which is a very critical thing right here. So which arrangement enables hot water to move freely to the water tank and cooler water to return to the solar panel? All right, so let's look at the diagram right here, which is the most effective one. So let's analyze them and talk about what is happening. Remember, first thing you need to remember that hot water will rise, right? So it's easy for that water to rise. Very important thing to talk about. So looking at tank A, for example, if the water going to be heated, right? If water going to be heated and go all the way up here, right? Then the problem is this, is that the hot water going to travel from the bottom all the way up. The cold water going to be here, which is going to be a difficult thing to do, right? Because all the cold water will be pushing down here and it'll be very difficult to move the heater coming all the way up. So it's going to be a difficult distance here. But this is not too bad, but it's kind of difficult for the fact that the heating portion here is all the way to the bottom, right? Now, and not only that going to happen here, the effectiveness of heating the water too will not be so good because the cool water comes in here, all right, and it's going to take a little longer time, and then to pass up here will not be effective at all. It's going to be very difficult to push up. Now, for option B, the heating element is right here. So the cool water pass through the entire thing, and then the water here going up, which is not a far distance from the heating element. So all this water here will be hot water coming up here. And so for water to leave this point to going up to the tank is not bad. Then the cool water will drop here. So most of the tank up here will be hot. And then the bottom here will be cool. So let's put H there. This will be cool. And the cool water fall into the heating element, which is, or the solar panel, going through the solar panel, which is kind of cool. All right, so this is not too bad as well. All right, so let's go to C. And C here, the water, the hot water comes from the solar panel is here, right? And the solar panel is on the top. And so therefore, the hot water goes down into the tank. And then up here will be hot. Down here will be cool. There's no way the cool water could go up here. No way it could go up at all. No way possible. Because it's going to be too cool. So the particles move slower. Cannot go all the way to this distance. So this is totally out, definitely for sure. But this one again, matter of fact, once the solar panel is on top, right? And the solar panel is on top, difficult for the water to go back up. All right, because again, cool water need to go up into the solar panel to get warm. So definitely they are not correct. All right, the cool water will not able to go into the panel at all. But let's go back to these two diagrams, which are critically good. All right, again, based on the fact that water is going down, the cool water is going down into the tank, you give it a lot of time to get warm. So while the cool water is at the bottom here warming, all right, it can move up each time, getting warmer and warmer, and then go up into the tank because warmer water will rise, okay? And so B will be the most suitable design, all right? A is not bad, but the difference with A is that you have a longer distance to travel with the warm water, okay? That's the only difference right here. This is a little bit more effective. A is not a bad choice, but it is not as effective as B, okay? Because by nature of the cool water, going to fall down to the bottom anyhow, right? So that's a problem. But warm water, moving a shorter distance, is more effective. All right, so 40. Which element can usually be found in nature in free uncombined state? And this, you see, aluminum is there. We have barium, we have calcium, and we have gold. And so gold is not as reactive as the others. So therefore, gold will be more likely in a pure uncombined state, because aluminum could oxidize, right? And the others are really reactive substances, okay? All right. Now for 41, it said the diagram shows the junction of 3 wires, okay? And so we have 2 with arrows. And it said what amount of current and its direction as it flows through X. So what is the amount of current and its direction as it flows through X? So first and foremost, you notice these 2 arrows are coming in this way. So all of them will meet, and then this arrow will come down like that. So these 2 will meet at the junction, all right, and then send the current into X. So therefore, the total current going into X will be 5, all right. So it will be 5. So let's go down to see what is our answer there. It must be 5. And so between C and D, and it said 5 towards the junction, or 5 amperes away from the junction. And so you're going to go away from the junction because it's going into X, okay? All right, so 5 amperes away from the junction. Because what they mean towards the junction, meaning moving from X, going that way, which is not true. So you come away from the junction into X, not towards the junction. All right. So now let's go to the next part of the question right here now. Our next question is a 42, and we're almost there. It's at which rate does a lamp of 60 watt, right? Rated at 60 watt and is a 120 volts transfer electrical energy. First thing I want to point out here is that electric power is the rate of transfer of energy, okay? So just to point this out, power, which is in wattage, it is the rate of transfer of energy. So in other words, it is electrical energy over time, right? Is electrical energy over time. Just to point it out, okay? So again, energy, or you can say joules over second, because energy is measured in joules and time is measured in seconds. So joules over seconds. All right, so first and foremost, again, as I mentioned, that once you talk about power, you talk about the rate of change of what? Energy. So if it's rated at 60 watt, means that it is the rate of electrical energy transfer is also 60 joules per second. That's what this information is telling you, okay? All right, so that is B. Now let's jump to the next question here, 43. Which substance would cause universal indicator to turn purple? Okay, and here we're going towards a base, because remember, universal for acidic substances will be from red going towards yellow. Green will be neutral, okay, and going up from greenish blue all the way to purple will be base. And so the only base we have right here now is our sodium hydroxide, right? Orange juice is acidic. Hydrochloric acid is acidic. Milk containing lactic acid can have lactic acid in it. It will spoil the matter of fact. All right, so you have lactose in it, lactose sugar. It may have lactic acid if it's spoiling. All right. It also have some calcium, so it could be basic, but it would be very low, very, very weak base or very weak alkaline. So it will not show much of a purple. It may more likely be between greenish blue instead of being purple. But sodium hydroxide is a strong base, so definitely it is the correct answer. All right, so 44, the graph shows the changes in lactic acid concentration in the blood as a result of vigorous exercise. So we have a lactic acid concentration in blood on the Y and time there. It's a which statement correctly describe the metabolic process that caused the increase in lactic acid. So what could cause an increase in lactic acid? Now we have aerobic respiration for A and B. Aerobic respiration does not cause an increase in lactic acid. That's the first thing you need to think about. Aerobic respiration, right, does not cause any increase in lactic acid. Now, when you produce lactic acid is when the muscles are respiring anaerobically. And I said muscles to point it out. And so let's read through the statement. For C, it's a anaerobic respiration result in the incomplete breakdown of glucose in the skeletal muscle. Yes, that looked good. All right. And for D now, it's a anaerobic respiration result in the complete breakdown. No, that is not true. So that is not in the smooth muscle. That make it worse. So complete breakdown of glucose is not true. Smooth muscle is not true. But yes, in the skeletal muscles, definitely. That's why you feel cramping in the muscles when you run for a very long time or you do very vigorous exercise, because you produce lactic acid there by anaerobic respiration. So C is our correct answer. 45. A Royal Bahamas Defense Force Marine sees the flare from a distress rocket in the sky, and 5 seconds later he hears the blast. How far is the distress rocket from the Marine? Now, speed of sound is 330 meters per second. The time taken for that is 5 seconds. First and foremost, I'm going to give this formula. Velocity is equal to distance over time. Just remember that, okay? So therefore, we want to find time. You want to find distance, a motherfucker. I say how far. So distance will equal to velocity times time, so V times T. So therefore, V times T are going to be 330, okay? 330 times 5 seconds, which will give us here 1,650. 1,650. Yep. And so our answer right here will be D. Okay. All right. So answer there will be D for 45. Now for 46, it said the apparatus is used to detect the presence of water and carbon dioxide in air. And so we have air going in, the damp air going in. We have the going towards the pump right here. This is anhydrous copper sulfate, and this here is lime water. And it said which row shows the result if water and carbon dioxide are present. So if water is present in the damp air going in, so there's something going to happen here. The anhydrous copper sulfate is without water, so kind of a whitish substance. All right. And so it's a which row now shows the result. And so for X, if you add water to anhydrous copper sulfate, it returns into blue. Okay, it returns really blue. And then if carbon dioxide passes through lime water, the lime water will become milky. So our answer there will definitely be B. Okay, without even going any further. So it will be B. The X, which is the copper sulfate, will become blue. And then lime water will be milky. So B is our answer right there. 47. It said 2 cars starts from the same point at 5 a.m. traveling in opposite direction at 40 meters per second. No, not 40 meters per second. 40 kilometers per hour and 50 kilometers per hour, respectively. It said at what time will they be 450 kilometers apart? So if you think about the 2 cars at being 450 kilometers apart, right? Now we don't know which car travel what distance, right? But the fact that they are 450 kilometers apart, what we can do is to say, okay, get an average. We can work out average distance and average time. Okay, that's the only thing we could do right here. So the average distance between the 2 cars, let's say they reach well, they're going to reach in different time, but again, average distance, let me do this in type. Okay, so the average distance here will be 450. Let me continue with this. So it'll be 450. That's the average distance between both cars. 450 over 2. Okay, so the average distance between the 2 cars will be 450 divided by 2, which gives you 225. Okay, so we're working with that as our average distance, right? Now, the next thing we want to work out here now, since we had to define the average distance for each car, we already know the speed, right? And so what we can also find is a time, because if we have the distance, so this is in kilometers here, and we have the speed, and remember from our formula I talk about up there, is that speed, if V is equal to D over T, then T, all right, let's do this. So V is equal to D over T. Then to find time, all right, time will equal to D over V, okay? So time will equal to distance traveled over velocity. All right, we have both velocities here. So 40 and 50. So let's work out the average time for each, okay? And so let's work out the average time here. So let's go for the 40 one. So we're going to work out each of them travel average 225. So for the van here will be 225 divided by the speed of that van, which is 40. That will give us an average time of 5.625. So 5.625, and that is in hours. So let's put hours there. For the other van, no, for the car, in fact, that's not a van, that's a car. So for the car right here, this will be 225, right, divided by the speed again, so distance over speed divided by 50, and that will give us here 5.0 no, this is 4.5. Yep, so this is 4.5, right? And this is hours again. Now, if you find the average between these two times, I'm going to find the average between these two times now. I'm going to add them and divide by 2, okay, to see the average time traveled in the entire motion. So the average time right here, we're going to add both of them together. So if I add both of them together, I will get, all right, so let's put it here. So we're going to put, let's put it at the bottom, right? So I have some more space. I'm going to find the average time here. So all I'm going to do is add 5.625 plus 4.5, all divided by 2, and that will give us an approximate time here of 5.0625. So that will be our average time that both cars will end up being 450 meters apart. That's the average time. And so if the average time is this, right? If the average time is this, then we can clearly state is 5 hours later, or 5.0625 hours later. So at what time it will reach there? Remember, the starting time was 5 a.m., right? So if I add this time, which is the 5.0625 hours, to 5 a.m., what you end up with, we're going to be like 10 hours and a couple of seconds, right? And so therefore it will be C, the 10 a.m. will be our answer right here, only 5 hours later. So an average of 5 hours later, both cars will be 450 kilometers apart. All right, so great. Now let's go to 48, and we're almost out of here. It's the table. The table shows the volume of 2 breaths of air, and 1 breath was measured when the person was at rest, and the other was measured after running a race. So 450 is at rest, and 1000 is after running a race. And so here now it said what would be the volume of carbon dioxide in the breath of air taken after running. So first and foremost, you need to think about the amount of carbon dioxide that is present, all right, that is present in that air when you breathe in air. So again, when you're taking the carbon dioxide, the average amount of percentage of carbon dioxide that it takes in is 0.04. So I'm going to write that down. So carbon dioxide intake is approximately 0.04. That is the percentage of carbon dioxide you take in. So let's say 0.04% of 1,000. And how you could do that, you can just simply divide this by 100, multiply by 1,000. Okay. All right, so let's do that real quick. So we're going to find 0.04% of 1,000. So again, we can simply divide by 100 here, and then we multiply by 1,000. All right, or you could just simply multiply by 10. All right, that's an easy way out if you understand that mathematics right there, right? So it could be, let's give you the answer right here. So 0.04, which is a turn in percentage, change this in the percentage into decimal, divided by 1,000. All right, let me just say multiply by 1,000, multiply by 1,000. All right, and this will be here divided by 100. All right, so let's put it right there like that. So you understand exactly what I'm doing here. And again, if you understand this, you could just cross out the 2 zeros here, cross out these 2 zeros, and just multiply the 0.4 by 10. That will also give you answer as well. So if you should multiply 0.04 by 1,000, then divide by 100, your answer here will equal to 0.4. So 0.4 will be your answer. However, all these answers are not in 0.4, right? But again, this is the approximate percentage. So anywhere from 0.04 to 0.3 is also correct. So answer here will be B, okay? Because again, it is an approximate percentage, but they use 0.03 as the percentage of carbon dioxide, okay? So B is our correct answer. All right. Now 49, for 49, it said that a man uses a camera to take a photograph of himself. His eyes respond instantly to the flash. Which part of the following describe how his eyes change? And remember, is responding to a flash, which is a bright light. So if it's a bright light, that means the pupil will decrease to prevent a lot of light going in. So the only two possible answers right here will be pupil decrease, so we know that part. So increases will be incorrect. But what happened to the iris? Remember, the iris controls the size of the pupil, right? So if the pupil will decrease, that means the iris must increase. Remember those finger-like things, if you look at the eyes from sideways, they're going towards each other. So if they go closer, that means the pupil will get smaller, so they have to increase in size for the pupil to get smaller. So C will be your correct answer right there. All right. Last question, and we're out of here. All right, so this is a simplified diagram illustrating the greenhouse effect. All right, reflected heat from, so this is reflected heat right here, and this is the surface of the earth, and this is the sun, and this is a layer of gas. And so this question now asks, which gas in the atmosphere is mainly responsible for reflecting heat? And if you remember the greenhouse effect, the gas that is the greenhouse gas right here is carbon dioxide. Carbon dioxide in the atmosphere will cause global warming, will cause the temperatures to increase, and simply because it is reflecting heat onto the surface of the earth. And that is why carbon dioxide emission is not good, because it leads to global warming. Global warming could lead to a lot of stuff such as the ice cap melting, flooding taking place, climate changes, and all of those type of stuff. All right, so here we're going to stop right here. Again, good luck on the examination. Do well. I'm looking for some A's. Come and report to me with your A's. Do good. Take care.